This video is provided by Carrier Enterprise, your complete HVAC distributor. Servicing on HVAC equipment should only be performed by licensed HVAC contractors. In today's lesson, we're going to look at reversing valves and their operation. This is a picture of a typical reverser valve that can be found basically in any residential heat pump unit. It also sometimes is referred to as a four-way valve, which is because of the four ports that are attached to it. Here we see the valve body, as well as you see four ports coming in. This one's kind of difficult to see here. Also, you'll notice this solenoid coil here, two wires coming off. In a four-way reversing valve, there has to be the ability to shift the valve from one position to the other, from the cooling mode to the heating mode. In Carrier, Bryant, and Payne manufactured heat pumps, we use a 24-volt solenoid coil to energize this solenoid valve in our heat pumps, and we do it on the cooling mode. As you see the capillary lines coming off the valve body here, we're using a pressure differential of at least 50 psi to shift this valve. Any differential less than 50 psi will cause the valve not to fully shift. Let's look at a more detailed picture. As we look at this four-way valve in the cooling mode, we see now that in the cooling mode, our hot discharge gas coming off our compressor is being channeled on through to the outdoor coil, which is our condenser coil in the cooling mode. As we see these capillary lines coming off the valve body up to the solenoid valve, and now you see it here on the right side, notice the color of blue versus the color of red kind of depicts the refrigerant state as it comes through the valve. So we'll see here that our head pressure coming through our capillary tube has pushed the slide mechanism over to the right, which is causing the refrigerant to allow it to pass from the compressor on through to the outdoor coil. And our pressure differential greater than 50 psi again is needed to be able to shift this valve all the way over into the cooling position. We see here that our suction has come from our indoor coil, our low temperature, low pressure gas comes from our indoor coil and then is channeled on through to the accumulator and of course then on to the compressor. This is the valve as seen in the cooling mode. Let's look at the valve in the heating mode. Now we see that the solenoid valve has been de-energized, which allows the solenoid coil to shift back, and now we see that our head pressure is now channeled through our capillary tube into our valve body and has pushed the valve slide mechanism to the other side of the valve. Now our hot discharge gas comes out of the compressor and is now channeled on through to the indoor coil in our heating mode, which in our heating mode our indoor coil becomes our condenser. And we see our low temperature, low pressure suction gas coming from our outdoor coil, which is our evaporator, is being channeled into the valve and then out through to the accumulator and of course then on to the compressor. So we see the valve shifted in both positions, both the heating mode as well as the cooling mode, as we see in this picture here. So now you've seen the valve in both modes. Now here's a drawing that I like to show, which is a very simplified drawing. As you can see the slide mechanism here that groups the ports together, either allowing the refrigerant to come through from the discharge and either go out to the left, which in this case would be out to the condensing coil, or allow the refrigerant to come through the discharge and go out the other side, which would take it into the indoor coil in the heating mode. So again, just a more simplified drawing, but it shows a real good picture of this kind of the idea of what this slide mechanism looks like on the inside. Also, you're going to see points labeled TP-1, 2, 3, and 4. And that's test points. To accurately diagnose whether the valve is truly seated or not, in the heating or the cooling mode, we'll have to take temperature measurements on the valve where the refrigerant enters the valve and leaves the valve. So we see here the test points of where we would measure the valve. And what we plan to do now is take you to look at a live unit and see what this valve looks like mounted in the unit. This video was brought to you by Carrier Enterprise, your complete HVAC distributor. We carry a full line of Carrier, Bryant, and Payne equipment. For more information or to find a location near you, please visit carrierenterprise.com.